Hello and welcome to the 1895 podcast with me, Thomas D.
And me, Rob Cockerell.
And Rob, it's great to be back here in Utrecht, isn't it? For the benefit of the tape, we should say we are recording this live at our European Specialty Gas Summit 2025 in Utrecht, and the second time we've done it here.
It is, and double Dutch this year, Tom. We're in Rotterdam in March, of course.
And recorded a live episode there, so if you're in the room, if you're listening to this, then do go back and listen to that. Wherever you get your podcast, just search the 1895 podcast. But great to hone in on specialty gases today, isn't it?
Absolutely, and we've got our guest on stage as well, Tom, so let's join him.
Yes, thank you for joining us today, Rich. We'll get into some discussion with you shortly, but perhaps first we should maybe explain the 1895 podcast a little to those who might not be aware. There's plenty in the room here who I'm sure won't be aware. So 1895, why?
Well, first of all, Tom, good point you made in the last couple of days. I think more than 60 episodes, so hopefully people are becoming familiar.
Hopefully so.
But yes, 1895, a pioneering moment in the birth of the gases industry as we know it today, of course. Carl von Linde, liquefaction of air, and we were paying homage to that forefather of the industry.
Yes, and that was 130 years ago in May, that was, and also very relevant today because, in fact, yesterday was Carl von Linde's birthday. So perhaps that hence the balloons at dinner yesterday.
Good fact, yeah.
Yeah, maybe he wouldn't be too keen on the branding on those balloons. But Rich, as we said, thank you for joining us today on the podcast. Perhaps for those unfamiliar with you, you could just introduce yourself.
Sure, thank you. First of all, thank you for inviting me to attend the conference and this podcast. I really appreciate coming here to Utrecht, a beautiful city, and I look forward to a good discussion here this morning. My background is that I worked in the semiconductor industry for 35 years. I'm a graduate of a university in Canada, moved to Texas to work for Texas Instruments for 10 years, and then started my own materials company in the semiconductor industry, which I ran for a number of years, took it public in the 90s, ended up retiring in 2016, and when I heard about the helium shortage, which was just starting in the 2019 timeframe that I was reading about, I approached Air Liquide to find out if they might need some assistance in finding new sources of helium in the Americas. They were happy to hire me, and so I started working at Air Liquide in 2019. When COVID hit, my boss decided to go back to Germany and take a different job at Air Liquide, so I took over the operation of running Air Liquide's helium business in the Americas, which stretched from Canada to Argentina. I did that until the middle of last year, or the end of last year, when I left Air Liquide. And since then, I've been working as a consultant on helium-related and industrial gas-related products, including various isotopes that I got involved with when I was at Air Liquide that I found interesting and in need of some additional support. So I've had a long career. I've worked in a number of different industries. Haven't worked for very many large companies, mostly just Texas Instruments, and then, of course, here more recently, Air Liquide, which was really a great experience. 66,000 employees operating in so many countries, and a lot of opportunities to bring my sort of entrepreneurial view of the world to a company that is not filled with what I would say a massive number of entrepreneurs. So it was a very enjoyable experience working there.
Fantastic, and clearly a real wealth of experience to have on the stage here, isn't it?
Yeah, I think it's important context for Rich being here on this episode and at the event, because you did spend the bulk of your career in the semiconductor sector, and you've got the other side of the fence with the gases industry. So
what's funny about that is that when I left the semiconductor industry in 2016, I had traveled more than 6.2 million miles on American Airlines alone. So I've never actually run into anybody who's traveled more on
neither have I. No.
Yeah. And that's just on American Airlines. That doesn't count the other airlines. So, but anyway, I left the semiconductor industry thinking that I was done with the semiconductor industry. I joined Air Liquide without fully realizing how much of their business was related to the electronics industry. And when I started in the helium business, almost the first thing I found out was how much helium they're selling right back into the industry that I came out of. So it was, because the part of the semiconductor industry that I was operating was on the materials side, but not the gases side. So even though I knew they were using gases, I hadn't really thought about it when I was there. So it's sort of a happy circumstance to find myself back talking to the same people that I was talking to for so many years when I had my own business.
And how have you found this event, speaking to those same people again?
Well, I don't know many of the people that have been at this conference, but I have so many contacts in the industry that actually several people have come up to me and we've been discussing who we know in the industry, and there's so much overlap. It's quite humorous to hear that everybody here is basically knows the same people that I know in the industry. It's not a huge industry, right? Like a lot of industries, it's quite closed.
What have been your highlights from the talking points and the agenda?
I think what's been really interesting here is to watch the collaboration going on between the individuals that are showing up at the trade show here. It's normally companies, vendors don't get a chance to have any conversations about what's going on in the industry, and situations like what goes on here at a conference like this are perfect for having those conversations in a non-threatening, completely compliant, legally arrangement where you can talk about what's going on in the industry and talk about what's important to the industry, right? For whether it's sustainability or reliability or safety, these topics transverse all companies. And they're things that everybody needs to be focused on, and this is a good opportunity into organizations like yours and situations like this for people to actually share their thoughts on these subjects.
It's great to see that collaboration, those conversations happening over the last couple of days, in the exhibition hall just through there and at dinner last night. It's great to see, isn't it?
It is fantastic. It's exactly what Richard described. You touched on a few topics there, and recovery and reuse is one of those. That's what we're aiming to discuss today, if we can, with your expertise. So perhaps we should dive into that. Maybe we could pull up our poll results if the team at the back are able to.
Yeah, and that was.
Bring those up.
We saw you teased those results earlier. Here we are. So where do you see the biggest need for recovery and reuse technologies? Helium out in front at 67%. Rich, using your background, is that a sentiment you agree with?
Well, okay, so let's talk about that. When I was working in the helium business at Air Liquide, this is a subject that comes up all the time. And it comes up for good reason. Helium is very expensive. And people are always thinking about recycling and reusing products that are either extremely expensive or extremely rare because they can't get their hands on them. And in fact, it's rarity that really drives most of the people into doing actual recycling. Let me explain that. During the helium shortage 4.0, which is a subject that everybody's heard about, the semiconductor industry was not put on allocation. Well, every industrial gas company decided, I think globally, that they would continue to support the requirements for helium for the semiconductor industry. Nobody missed a shipment of helium that needed it for a wafer fab. That was not true in other industries. Especially the MRI industry was really faced with the idea that they might be put on allocation, and many of those companies were put on allocation. So where do we see actual reduction in use and recycling being pressed the hardest is actually in industries like that. So it's the absence of the molecule that is a far greater motivator than just a higher price that really drives this idea of recycling. So what you see is that in the MRI industry, many of the people that produce the machines have installed massive recycling systems at their plants so that when they're loading the machines with liquid, they often have a quench. That gas oftentimes was just lost, but now they're capturing it, they're repurifying it, in some cases reliquefying it, and then reusing it at the front of the line. This is something that wasn't happening originally. And then the other thing that they did in the MRI industry is they designed the machines to use, the new machines use much less helium than the old machines. This was driven, again, by this idea that they were going to be allocated and that they couldn't get the product. Never mind the price of the product, they just couldn't get it. So why do you see this in the semiconductor industry is everyone is worried about the threat. If you own a $12 billion wafer fab and you need 3 ISOs, liquid ISOs of helium pulling up at the front door every month, you have to be thinking, if you're the purchasing manager, that what would I do if I couldn't get that because of the shortage? And this has driven a lot of this concern about the helium recycling in the semiconductor industry, even though they were never put on allocation. It's still a concern because of in a wafer fab, the most expensive, what is the most expensive material in a wafer fab? Anybody have any idea? What's the most expensive material in a wafer fab? Any answers? Somebody out there? I can't see any hands. Well, I think I heard somebody in the front row say it. The most expensive material for a wafer fab purchasing department is the one you can't get, right? It's worth what? Infinity. Because if you don't have it, what happens? The fab shuts down. And if you have a $12 billion wafer fab and you're the buyer who's responsible for product X, Y, or Z, and you can't get it, well, what do you suppose is going to happen to you, right? When I did a lot of sales in my time, and one of the stories I always tell people that when I had my semiconductor company and they were going to call on buyers at semiconductor companies, they often would call the buyer and they would find out the buyer is not there. Where are they? And the answer is, well, they're at a training class. And so I would say to my salesperson, what do you suppose they're doing at that training class? The buyer, the salespeople always think that the most important thing is price. They always come back and they're saying, "Oh, the customer wants a lower price. They're beating me up on the price. They're making me miserable about that." So I would have these seminars where I would talk to our salespeople. I say, if the buyer's not there and they're at a training class, what do you suppose they're doing at that training class? Do you think that they need to go to a training class to know that 3 is less than 4? And that a lower purchasing price is, how hard is it to understand that 3 is less than 4? Obviously, when the buyers are at a training class, they're not there to learn that 3 is less than 4. So what are they talking about? Constancy of supply, reliability, quality, safety, all of these things, which everybody here knows are the most important things. But when you often go and talk to the customer, the buyers are constantly carping about one thing, and that one thing is price. Good salespeople know that price is never the key driver. It's always these other factors. So this recycling activity is driven often over this concept of, well, it's expensive, it's rare, we need to figure out a way to sustain ourselves, and one of the ways to sustain ourselves is to try to recover the product and recycle it. But inside a wafer fab, this is actually quite complicated. First of all, inside chambers, you have gases that come from a number of different suppliers. It's not just helium from one company and that's it. It's often mixed with something, and that something can be quite caustic. So who actually is going to be responsible for doing the recycling? I've been involved in discussions where they wanted us to take the product from the chamber away from the fab and purify it and bring back the helium. Well, imagine the liability of taking a product from a wafer fab that hasn't been neutralized. It's still caustic. Yes, there's helium in there, but there's also something else in there, as I like to tell the salespeople, something that could melt your face off. And you take it away to your plant off-site and tell the people there that they have to process it in some piece of equipment, a purifier of one kind or another, and something happens. First of all, I didn't sell them the caustic gas. I'm just trying to purify the recycle process to get the helium back. That's a problem on a number of different levels. Who's liable for that? That's the biggest one. Who's liable for if something goes wrong? This is why at a wafer fab, the most thing that they want to do with the gases that are coming out of these chambers after they've used them is what? Just same as the chemicals. They want to neutralize them, basically burn them and get rid of them. This is why they have smokestacks on the top of all these wafer fabs. It's because they want to neutralize that product and get rid of it so that the opportunity for accidents is minimized. If you have a $15 billion investment, what you need that wafer fab to do is to make wafers. That's the most important thing, right? Adding all this risk for doing non-core activities is often detrimental to the task at hand. However, that doesn't mean they don't want to try to talk about recycling, because if there's a simple way of doing it, they would absolutely love to do that. But they don't want any liability associated with that. They don't want to lower their throughput. Imagine if you had a recycling system that cost you 1% yield. 1% yield loss in a wafer fab that's making 60,000 wafers a month. This is a fortune, right, by the time you're talking about it. So these things all have to be put into balance, and that's why it hasn't been adopted on a broad scale in the semiconductor industry. There are people doing recycling of neon in certain areas where they're 100% sure that the only thing in there is air plus the neon. This is possible. But of course, even the activity like that drops off dramatically when the price of neon collapses, or any other gas where you're thinking of doing the recycling. If you know it's just with air, but then the price collapses, well, where's the motivation to go spend the capital on a recycling system? So again, they're already spending $15 billion to build the wafer fab. This idea that they're going to spend the extra capital on these extraneous business ventures is dubious if there's not a critical need for it. So if they see neon running out in the world, they might do that. But to do that for when it's not is, I think, a tall order for most of these companies.
And we heard yesterday about security of supply, especially on the helium front, and in fact we have got plentiful supply, even oversupply at times. So does this really take away from any reuse and recycling technologies out there?
Absolutely. When the price of helium is dropping and you go talk to the buyers at the wafer fab, the subject will not be recycling. I can assure you of that. It's going to be something else. They'll just be constantly asking for lower prices, back to the usual discussions that they have. But in fact, what they really want is constancy of supply. They want certification that the product's produced properly with the proper purity, that it's been handled properly, that the supply chain is reliable. They want to make sure they're not going to run out. This is why the department, purchasing department exists there. Yes, they want competitive pricing, but they cannot afford to have the fab run out of anything, whatever it is. They can't afford to have the fab run out of it. Which is why they're all pressing for local manufacturing. They love to have a vendor set up shop right next to the wafer fab so that they can literally run next door to get product. Or just-in-time warehouses. We saw people here today talking about putting in just-in-time warehouses. When I had my business, we had 21 just-in-time warehouses around the world when we were manufacturing in China. And we would ship to our own just-in-time warehouses so that they could keep safety stock close at hand. And then we would actually, don't tell them, but we would charge them premiums based on the amount of safety stock they wanted us to keep for them. If they wanted 1 week of safety stock, it would add X amount of price to the product. If they wanted a 1 month, if they wanted 3 months, we would do that, but it would, there would be a fee associated with that. But in many cases, this was something that the fabs valued. So the trick is to really understand what they want. Unfortunately, I must say that my experience is that a lot of people that sell into the semiconductor industry, having not been in the semiconductor industry, they don't really understand these critical aspects of what's going on, and so they get a little bit scared when you're walking up in front of a building that somebody spent $15 billion on. It can be intimidating. And I used to talk to my salespeople, don't be intimidated by the fact that building cost $15 billion. Yes, it looks like the Taj Mahal, it's true, but they need you, they need us, they need all of the people that are here in this at the show or anyone listening to this podcast. Without the vendors, you can't make the product, and they can't sell the product, right? And that's a problem. So they, at the end of the day, the most important people are their own employees and the vendors who supply them with the materials and the processes that they need in order to make the product. And that's true with materials. It's true with capital equipment. It's true with everything.
All of this is reminding me of the sentiments we heard earlier this morning in the session. Small asset, big picture. All of that is very relevant. You just mentioned the people in the room here. For everyone listening on the ground, you can throw in questions. Please do put some questions in for Rich. We'll get to those in just a couple of minutes. Another topic that's trending, Rich, depending what you read, helium-3. Perhaps you could give us a very brief introduction to what that topic is, what we should make of it.
So when I was at Air Liquide, I went to a seminar that the Rare Gases group was having, and they were lamenting the fact that they didn't have a source of helium-3. Linde was selling helium-3. Other companies had helium-3, but not Air Liquide. Through a strange combination of events, the fact that I'm from Canada, I helped them track down a source of helium-3 in Canada, and they signed a long-term agreement for that product, which has put them into the business. Since I left Air Liquide, I've put myself in the helium-3 business, and I've been buying and selling helium-3 in whatever quantities I can get, as well as some other rare isotopes that I got involved with at Air Liquide. But the helium-3 business, of course, is a very rare isotope of helium-4. All the helium-3 that we have that's here on Earth is all made from tritium, which has a half-life of 12.3 years and transmutates from tritium into helium-3. And this is where everyone who sells helium-3 is getting it from tritium. What's funny that I've noticed here in the last year and a half or so, or maybe 2 years, is that there's a lot of companies that are in the space business who are all trying to get to the moon or to Mars. And the ones that are trying to go to the moon are raising money to do so, and they have decided that the commercial reason for raising the money from the investors so that they can provide them a return on their invested capital is that they're going to go to the moon to mine what? Helium-3. That helium-3, they think, is needed for fusion reactors, which may be true. Of course, the number of operating fusion reactors on Earth right now is 0. So this is all aspirational, but it is a very interesting situation where almost every day I see 2 or 3 press releases from different companies that are all talking about taking equipment from Earth to the moon. They're going to set up some sort of a mining operation up there and bring the helium-3 back here to Earth, which is quite interesting and the subject of, I think, a much longer discussion.
We're the same at Gasworld, as I'm sure you can imagine. Seeing the news stories, we get a lot of speaker requests for events like this to talk about helium-3. In your view, is it something we should take seriously?
Well, you should take the discussion. You should take the discussion seriously because these people have raised hundreds of millions of dollars. The people that are in the fusion business have raised billions of dollars. The number of people chasing fusion reactors of one kind or another is probably 50 companies that have raised probably more in excess of $6 or $7 billion of private equity money that's come in from, I'm not talking about government institutions. These are private enterprises that have set up shop in Europe, in China, in the United States, all over the place. To try to design fusion reactors, and those fusion reactors take different forms. Some of them are using tritium or deuterium as a fuel, some of them are using helium-3 as a fuel, and some of them, based on what fuel they're using, will either create helium-4 or helium-3. So it's a very complicated picture, and helium-3 enters into that discussion as well, which is one of the reasons why these companies want to go to the moon to seek out helium-3, because it turns out that if you fuse 2 helium-3 atoms together, which would be the purpose of a fusion reactor, or the subject of a fusion reactor, you get very benign byproducts that are not radioactive. You only get a proton coming out, and you get helium-4 coming out. So you won't have any nuclear waste, which is very attractive. Unlimited power, no nuclear waste. This would be a dream come true for the world. But as I was just said a few minutes ago, the number of those fusion reactors that are operating on Earth right now is limited to 0, right? However, you can go to the sun, where they're regularly fusing, helium-3 and helium-4. It's a giant fusion reactor, right? But it just doesn't happen here on Earth yet, and it's quite complicated, right? Because the temperatures inside a fusion reactor are essentially at least the temperatures of the sun, and that's hotter than these lights.
And there you go, Tom. We've managed to get onto the topic of space again and take this into orbit.
Did this last year, didn't we?
We did.
About space a lot. So if we're not going to the moon for helium-3, where here on Earth are real hotspots for tritium and that helium-3?
So there are plenty of reasons to go to the moon. Hardly anybody in this room is as old as I am. I don't think either of you were probably alive when we set foot on the moon.
Not quite.
Not quite, right. So I remember, though, as a kid, being completely inspired by watching the Apollo program. Sitting on my living room floor, I was like 10 years old, and watching humans land on the moon and take those first steps and then safely return to Earth. That was very motivational for a whole generation of people. So we can call it STEM, right? Science, technology, engineering, mathematics. Going to the moon there's a very good reason to do that, to inspire the next generation of kids to become engineers, to fill this room with even more people that can come up with good ideas on how to make industry better, right? This is really critical to the world. So for that reason alone, it's worthwhile going to the moon. I'm just not sure that the commercial activity of helium-3 from the moon is really viable, especially because here on Earth, all the helium-3 is coming from tritium, and the tritium can actually be produced here on Earth. If you have a nuclear reactor, a regular nuclear reactor, and you take neutrons and blast sheets of lithium-6, you get tritium. And tritium, with a half-life of 12.3 years, turns itself into helium-3. So all of the helium-3 that we have on Earth is actually coming from tritium. If we need massive amounts of additional tritium for fusion reactors, which is possible, then we'll have to make it. But we can make it with a regular nuclear reactor. It's not impossible, and probably a lot easier than flying to the moon to get the helium-3.
I'm conscious we've only got a few minutes left, really, but also that you'll be speaking in the next session, Rich, and talking
Yes.
about helium. So if we just move on from helium for a moment, perhaps we go back to the poll results we had on screen a moment ago. Does it surprise you that helium polled so highly compared to the other gases, considering we're not in shortage 4.0, things are plentiful? Anything about those results that stood out to you with sulfhexafluoride, neon, for example?
Well, I think what's interesting about helium is that there's a lot of interesting things about helium. First of all, it's a global product that can't be produced. This already puts it in a category by itself, right? The helium that we have on Earth is coming up with natural gas. We're not making it. Every other gas that we're generally selling to the semiconductor industry are things that we can actually produce, right? So that makes it already something that stands out by itself, and that I think draws a lot of attention, because if you can't produce it, you always have to be worried that you can't get it, right? Because a shortage can pop up out of nowhere, and as we've discussed, there's already been 4 of them. So it doesn't surprise me totally that there's an absolute focus on it. But the innovation that has to happen in the industrial gas business, which I'm going to be talking about a little later today, it can happen from any different direction and for every different possible reason. And so we're going to talk about that a little more later. But the reality is that the innovation isn't limited to one product or another. It comes from every company that's here. That's every company that has employees that are thinking about how to make things better. I teach a class at the University of Texas on innovation twice a year to engineering students. It's one of my hobbies. And we're going to talk a little bit more about that this afternoon. But innovation is something that every engineer and technician inside a company, whether it's a vendor or the semiconductor company, this is something that should be a focus of these companies, because making things better is how we make advances to technology, and has certainly been that way from the dawn of time. And it's something that needs to be encouraged, so that there's a thought process inside every company on how to extract innovation from every employee. Everyone who comes to work has ideas. The company has to figure out a way to encourage those ideas and bring them to the forefront so that people can try them. Okay, a lot of ideas don't work. Absolutely the case, as I'm going to discuss this afternoon. Thomas Edison tried 10,000 different materials before he found the right material for the filament of a light bulb. Excuse me. This is something that comes with innovation, is that it's not a direct path, right? There's lots of twists and turns in the pathway. But if you're not encouraging that in your company, you're putting yourself at a strategic disadvantage. And ultimately, the companies that can be innovative, even in small steps, will make progress and have a much higher chance of being successful than ones that don't encourage it at all.
And I see we've only got a couple of minutes left, but to bring this to a close and to have a look towards the future, is there anything that needs to change in order to fully unlock the potential of reuse, recycling, or are we always going to have these natural cycles and shortages here and there?
I personally think that this will always pop up as issues when there are shortages. And when the shortage drops off, the motivation for the recycling drops off at the same time. And that's especially true in industry, because the goal of the wafer fab is not to recycle the products. At your house, you have, or at least I do, I have a waste bin that the city wants you to recycle different things, and you're willing to sort the things by different materials. But I'm willing to do that at my home. But if your business is to make wafers, and you're in a competitive industry where there's constantly people chopping at your ankles to take away your business, your focus is always on productivity, throughput, safety, reliability, and getting the most out of the wafer fab that you possibly can. If the absence of the material will cause you a great deal of grief, then yes, you're going to want to figure out if you can recycle the material. But if the material is plentiful, then your focus, by definition, is going to change to improving yield and throughput, productivity. These are the things that make a $15 billion fab worth $20 billion, rather than making the $15 billion fab worth $5 billion by having the thing fail, right? And semiconductor companies fail all the time, right? The world is littered with semiconductor companies that don't exist anymore, that have gone out of business. In fact, I've just been reading about Wolfspeed, which used to be called Cree, is on the verge of filing a Chapter 11 filing, from what I understand. And this is a silicon carbide company that's been under heavy competitive threats. And this happens all the time in industry. Companies come and go. So their primary focus is to do a good job and produce products that they can sell at good prices with good margins. Yeah.
Sounds like a conversation we're going to be having for years and years to come.
It does indeed, and some great sentiments there to bring this episode to a close with, Tom.
Yes, absolutely. So for those in the room, thank you for joining us in the room, in fact. And for those listening, then you can like us, follow us, share us. The 1895 podcast is what we're called, and hopefully we'll bring this back next year.
Absolutely. I'm looking forward to it already.
Yes, thank you.